In the last lecture, actually, we have discussed about the Turing machines, which is the abstract model of computation. The mathematician Alan Turing invented this machine during 1936. We have seen the basic notions of the Turing machine, and we have also seen the formal definitions. Now today we will see the examples how we can construct the Turing machines for some given language. See, Turing machine is general method for the computation. It is not only used for the language acceptor. You can compute any partial function with the help of Turing machine. So any mathematical function you can compute, any decision making cases you can do. So let us see one very simple example. Let us construct the Turing machine for the language L is equal to X, which is in the set AB clean star, such that X contains ABA as substring, as a substring. So this is the language we are having. Means like you have the B, B, A, B, A, B. This is the valid sentence of this language because A, B, A is there. B, B, A is not a valid sentence because it does not contain the pattern A, B, A. So we are interested in the string that contains only ABA. So this language contains all such strings that has ABA as the substring. And you know that by constructing the Turing machine for this language, you are not showing the power of Turing machine actually, because for this language you have also constructed the finite automaton. Just this example is for the demonstration how you can construct the Turing machine. So we have the initial state in the Turing machine, like we say it is the Q0, we have Q0 as the initial state. So this you can start from the Q0. And you know that we have the configuration in the Turing machine. In the last class, I have discussed you the configuration of your Turing machine. Means once you are having the tape and this tape is acting as the input as well as output device. So your at the beginning, your input is stored in this tape, and we have the notion that at the square 0, we have the blank symbol and tape head is scanning the blank symbol. Okay. And immediately after the blank symbol, means after the square 0, starting from the square 1, we have the input. And this input does not contain any blank symbol, means immediately after the X, say if your input is like, if X is equal to ABA, for example, then you have A here and B here and A is here. And immediately after the A, we have the blank symbol. And everything is blank here actually. We don't require to mention. Once there is nothing in the square of the tape, means it contains the blank symbol. Okay. So at the beginning, we have the initial configuration, and initial configuration is what? Your machine starts from the state Q0, and you have, say, we have the initial configuration where your machine starts from the initial state, and at the beginning, your step head is at the square 0, and immediately after the square 0, after the blank, you have the input. So this is the initial configuration. Okay. So if you are given some strings in this language that contains AB as the substring, then your machine is having like this. You may have the BA, if this is one of the configuration. So at the square 0, you have the blank symbol, and immediately after the blank, you have the input, and after A, you have everything is blank. So at the beginning, this is the condition in the tape. So you have to decide, your Turing machine should decide whether this is in the language or it is not in the language. So how it can decide? So your Turing machine starts from the Q0 and see what it can do. It goes to the state Q1, and first job is to, your tape head is at the square 0, so it has to read the input. So once machine start at the blank at the square 0, your tape head is scanning at the square 0, and it is the blank symbol. We don't require change the blank symbol. You can replace blank with blank, and you have to move to the right side. So once you are going to move to the right side, you are having some input. So now it can be B. So if it is B, then what you need to do? You don't require to do anything, because you don't worry about the B any okay. You are just interested in what? ABA, whether ABA is there or not. So you are just searching the pattern ABA. So you are interested for the ABA. So if input is B, means tape symbol contains B, replace with B and go to the R. Once you go to the R, then you are having this symbol. The next square, it is B, then see, again you have the B and replace with B, go to the R. Then whenever you have the A, so what you need to do? Whenever you have the A, then you are supposed to change the state, because you want to remember that yes, you have found first A, so A replace with A and go to the R, right side, and say this is going to the state Q2. This is the Q2 you have. Once you are at Q2, then you may have the input A also, means you have the further A. When you have the A, then what you need to do? Again, you remain in the same state. If it is A, replace with A and go to the R. Whenever it is B, then you have, so if it is B, then replace with B and go to the R. You are going to the state, say for example Q3. Whenever you are at the Q3, you may have the input B again. Once the input is B, then what you need to do? You have to come to the state Q1 again, because you have, again you need to search the pattern. So from the state Q3, you should come to the state Q1, and while coming to the state Q1, for the case of B, you have the B, replace with B and go to the R, like the things. So again you are interested for searching. If you have the B again, then you remain in the same place. If you have the A, then you go to this place, then B, go to this place. And if you have the so you have seen the transition for A and B here, here also A and B. Once you have the input A, then what you need to do? Whenever you are at the Q3, so you have AB, okay. And again, if you are getting the A, this means ABA is matched. The pattern ABA is found. So A replace with A and go to the R. Now machine has obtained the pattern, and as soon as machine is able to find a pattern that we are interested, ABA, it says that yes, this string contains the ABA as the substring, and hence this string is in the language. So it decides to halt. Why it is halting? Because this is the valid string now. So see the situation. In this case, as soon as you may have the situation like this, you have A, B, A and B, 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 A, B, like the things. You may have the input like this. So whenever you have the A replaced with A, go to the R. Then you have the B, you are here at the state Q3. Whenever you are at Q3, you have the A, and your machine goes to the halt state. Why it goes to the halt state? Because ABA is matched, and it means is this string contains ABA as the substring, and your Turing machine comes to know that, decides explicitly that yes, the given input is in the language, because ABA is the substring. And once it decides explicitly, then it goes to the accepting state, halt state, and your machine halt. And you know that once your machine halt, then further move is not possible because transitions are not defined for the HA and HR. You have the transitions are only, you are defining the transition only for the states in the set Q. You are not defining, and you know that the Q does not contain the states HA and HR. So HA and HR are not in the Q, and you have defined the transition for the states in the Q only. That's why once your machine decides explicitly that yes, given input is in the language, it goes to the halt state, and once machine goes to the halt state, whether it is HA or HR, further move is not possible. So this is the difference as compared with your PDA and also as compared with the finite automaton, where in case of FA, even you have reached to the final state, you have to consume the complete input, means you have to read the input completely. In case of the PDA also, you have to, even you have reached to the final state, and if you have further input to be read, you have to read the input. And once the input exhausts, then you can decide what is the state in case of the PDA or in case of the FA. And once your input exhausts and your state of the machine FA is final state, then this is the case of acceptance, and also similar is the case in the case of the push down automate. But here in case of Turing machine, this is the difference. As soon as machine explicitly decides that okay, the given input is in the language, then it does not require to read complete input, just Turing machine goes to the halt state, accepting state, and halts, stop, and further move is not possible. So here we have seen that HA, okay, and we have the case of rejection also. You have the other state, which is the, your machine can also go to the HR. And what are the conditions when your machine goes to the HR state? Whenever you are in the state Q1, okay, and your job is to find the string that contains ABA as the substring. Now, once you are at the state Q1, so at the beginning you have the square, at the square 0 you have the blank, replacing with blank go to the R. Whenever you are at the square G1, then if you found instead of A or B, if you have the blank again like this, so if this is the tape, okay, and this you may have the conditions, this is 0 1 2, if you, this is the blank symbol, okay, again you have the blank symbol. So somebody can give the null string, means nothing is there, means null string. So what you have, once you are saying that blank replace with blank go to the R, your at the beginning your tape head is at this place, then it moves to the right. So R means you are going to the right. And again if you find the blank symbol, then this is not in the language because this is null string and it does not contain ABA. So from this state, if this is the condition, then you have to go to the state HR. This is the state HRC. So from here you can go to the HR state. For what cases? You have the blank, replace with blank, and you may move tape head right, or you may not move, you may keep stationary also, there is no issue. Now whenever you are at the state Q3, so once you are at the state Q3, you have read B and A, and if instead of again finding B or A, if you have the blank symbol here, then clearly the string is not in the language, because you know that at the beginning in the tape contains only the input. So at the beginning the tape contains only the input, and input does not contain any blank symbol. String X does not contain any blank symbol within it. So immediately after the completion of the input you have the blank symbol only. So the input is having no blank symbol. So that's why whenever you find that if you are at the state Q3 and you observe that okay, the input is not in A or B, it is blank, the square containing the blank, then this is the case of rejection also, because this string does not contain the ABA as the substring. So here you have the blank, replace with blank, and go to the R. Now if you are at the Q3, instead of input A and B, if you have the blank, then again the string does not contains the ABA, so it goes to the HR state. Immediately machine decides that, okay, yes, this is not the case of acceptance, and hence it goes to the rejection state. Okay. So these are the situation. If you are at the Q1, if you have the blank, if you are at the Q3, if you found the blank, and if you are at Q3, this is the state Q2. Once you are at the Q3 and you have the blank symbol, this is the case of rejection. So once this is the case of rejection, then your machine explicitly goes to HR state. Now see the situation. So in case of the Turing machine, if you have the input A and B, okay, input symbol contains A and B. So here you have shown the transition for A, you have shown the transition for B also, okay, and this is the favorable cases. And if you have the blank symbol here, then this is the case of machine explicitly decide that, okay, the given input is not in the language, and it goes to the HR. And as soon as it goes to the HR, this is the halt state, and machine cannot make the further moves. So, but for the simplicity, actually, once we construct the Turing machine, then generally the situation for the rejection, we are not showing the actually for the simplest diagram of the Turing machine, we don't show the transitions of that goes to the HR state. Means whenever you are at the Q1 and if you have the blank symbol, this is the situation of crash. Machine is going to crash. Okay. So whenever you are at the state Q1 and you have the blank symbol, but you have not shown the transition, and this is the situation of crash. So you don't require actually to show the transition for the HR state. So for the simplest diagram, we don't require to show the transitions here. In the simplest diagram, just you show the transition for A and B, and if you are at the state Q1 and if you have the blank symbol, machine will crash. Means machine will crash means machine goes to the HR state. Rejection state means explicitly your machine is able to decide that, okay, the given input is not in the language. So we don't require to define the transition that goes to the HR state. For the simplicity, if you are showing the transition, then there is no issue. But for the simplifying the diagram, we generally don't show the transition for the situation that leads to the HR state. Okay. So you don't require, if you say explicitly in the next, whenever you are going to construct the Turing machine for some language, you don't require to show the transition that is not in favor, means for which your Turing machine explicitly decides that, okay, it is going to the HR state. So generally you will have the HA. And also here you don't require to double circle. Okay, so HA you don't require to double circle like PDA or FA. You just write HA because HA denotes the acceptance condition. Once machine halts in the state HA, means this is the case of acceptance. Okay, so this is one example where you have seen that as soon as your machine identifies that, okay, yes, decides that, okay, the given input is in the language, it goes to the halt state. Even the input may not be read completely. In some cases, like if you consider the language, if you have the language L, which is X, set of X that taken from the AB clean star, such that X ends with ABA. If you are given the language like this, so every string is valid if you have the last three symbol is ABA. And if you construct the Turing machine for this case, then your Turing machine has to read the input completely, because once it goes to the end of the strings and once it observes the last three symbols ABA, then it decides that okay, yes, the given input is in the language. So for this language, Turing machine has to read the input completely. But for the language that contains ABA as the substring, machine don't require to read the input completely. As soon as it found the pattern ABA, it decides that okay, the given input is in the language. So you have the situation like this, and like you have, if you go for the Turing machine for this case, then how you can construct? You can have the initial state. You are say Q0. This is the initial state, and every time we have the situation like this. Every time we have the input, and the input is stored in the tape, and at the beginning this is in the square 0, and your tape head is scanning the square 0. So from 0 you have to go to the state, you have the blank, replace with blank and go to the R. So once you are at the state R, you have the input B. If you have the B, you can remain in the same place, because you are interested for the ABA pattern. So it is B, replaced with B, go to the R. Once you go to the R, you have the A. So for this case, if it is A, replace with A and go to the R, like this, and you are at the state Q2. Whenever you are at Q2, you may have further A. So again A, replace with A and go to the R. Whenever you are at Q2, and you may have B. So you replace B, replace with B and go to the R. And this is the state, say for example Q3. You are going to the state Q3. Okay. Whenever you are at the Q3, so okay, A, B, and if you have found, you have the A, B, and if you are at the state Q3 and if you have found the input B, then where you can go? Whenever it is B, then you can go to the state Q3. So from the Q3, you can go to the state Q1. So for the case of B, replace with B, go to the R. Okay. Now, whenever you are at the Q3, so A, B, A. Okay. Once you have the A, then you have to replace with A and go to the R. You are at the state Q4. Now, ABA, even you have found the ABA, and you cannot, your Turing machine should not go to the halt state, because ABA should be in the last. It has to read the input completely. So what you need to do, once you are at the state Q4, so you have to read the input again. What you need to do, ABA. If you are at the state Q4, you may have the A or B. If you have the A, where you can go? So you have the ABA. If you have the A, then you have to go to which place? This is. So you have input is the A and replace with R. If you are at the state Q4 and your input is B, then what you need to do? A, B, A. So you can go to the Q3. So if you are going to the Q3, then this is for the case of B. Okay. So once your machines observes the symbol blank, whenever you have the blank, replace with blank, go to the R, and this is the HA state. This is the H. And you go to the halt state. And you know that everything after the input is blank. So you have the blank here. So whenever you are at the last, whenever you have read A and you are at the Q4 and you are moving to the right and your tape head is at the blank, once it found the blank symbol, it means your input exhaust. So once input exhaust, it goes to the HA state. So this is the example where your machine has to read the input completely. Okay. Now let us see some more complex example. See, we have the language of palindrome. So we need to construct the Turing machine over, say we have the two symbols A and B. So like we have this language L, and this is the set of string X, which is taken from the AB clean star such that X is equal to XR. Okay. So now see, in case of the PDA, we have seen that if you have such situations, then deterministic PDA is not possible. And also you cannot construct the FA for this language. Now you will see here, you have the deterministic Turing machine for this case. So how you can go for the deterministic Turing machine, how you can construct Turing machine for this. So you know, we have at the beginning, we have this situation blank. You may have any input like this. So you have the A, B, B, A, for example, you have this situation. And this is the situation. At the square 0, you have the tape head. And at the beginning, you have the input A, and everything is blank after the input. So this is the situation you have. So what you need to do, since you have the tape and now you are free to move the tape head to the left or to the right, there is no issue here. So what you need to do, these two blank symbols are just like a marker of these two ends. So you can, after the blank, you have to consider what is the input. Say this is the A, then you have to just go to the end of the input, and which is this is the end, and you see that if this is A, then this last must also be A. And you can delete, for example. You can delete. And now you have to match this. You have to see that second input must be the second last. So you have to match this is again surrounded by the blank. So this is just like the marker. You are keeping the two finger at the two ends, and you are matching the first symbol with the last symbol, second symbol with the second last, like the things. So this is the way you can match, and your Turing machine will jump from the beginning to the end, then from end to the beginning. So your Turing machine is like this. Now we construct the TM for the case of the language of palindrome. So how we construct? Your TM starts from the initial state. So you have the initial state. Q0, and your first job is to go to the input, means, so what you need to do, you have the blank, replace with blank, and go to R. So you are going to the state, say for example state Q1, and once you are at Q1, you have the input now. So you have two situations. You have either A or B, and see, you need to match the first symbol. You have the A. If it is A, then last must also be the A. If it is B, then last must also be B. You have to match. So how would you remember that you have read A? So for these two situations, A or B, you have to go to two different places. So if it is A, then say you are going to this way. So Q1, Q2. Okay, say if it is A, what you need to do? You have to, these blank symbols are just like the markers. So you just delete it, but remember that what you have deleted. So you are reading A, and you have deleted this and go to the R. Once you are going to the R, you are in this next input, next square, and at the square, at the state Q2, what you need to do, whether it is A or B, you have to replace and move to the right. So B is there, replace with B, move to the right. You just scanning. So you may have the A, B, like the things. So you just scanning and move to the right. So when you go to the right, say if A is there, replace with A and go to the right, and you have the blank symbol. So whenever you have the blank symbol, what you need to do, replace with blank. You have the blank, replace with blank, and what you need to do, come to the left, because you have to come to the last input, last symbol. So if you are at this place and you have the blank symbol, replace with blank, come to the left. Once you are coming left, means you have the last input. So this is the, say this is the state Q3 you have. This is the state Q3. And once you are at the Q3, and if this is the case of correct input, then you must have the A, because you have started with A and you have deleted here. So this must be A. So you have to show the transition for the A only. So you can say this is A, replace with blank and come to the left. So this A you have deleted. Now come to the left, and this is, say, state Q4. This is the state Q4. So if A is there, replace with blank, come to the left. Whenever you are at Q4, what you need to do? You have to scan to the, coming to the left. So whatever you have the A or B, if you have the A, replace with A and come to the left. If it is B, replace with B, come to the left. This is it. In this way, once you are coming, you have the A, replace with A, come to the left, B and A, replace with A, come to the left, you are now blank. So whenever you have the blank symbol, once you encounter the blank symbol, okay, so whenever you have the blank symbol, what you need to do, you have the blank, replace with blank and go to R. So you are going to the R. So when you go to the R, you have the further input. Say again you have the A, replace with blank, go to the R, and at the Q2 you have to scan for A and B, small A and B. Whenever you have the blank symbol, whenever you observe the blank symbol, come to the left. You are here, you have started with A, and delete this. So you have deleted this and come to the left. Once you are at the left, you have the B here, and this B you can scan, and whenever you move to the left, then again you are going to scan this blank symbol. So replace with blank, go to the R. When you go to the R, now you have the input, which is the B. Now you have to remember, now you are reading the B. So Q3, Q4, and this is, you can say, this is Q5. Okay, and from this way you are coming to this way. So input is B, replace with blank and go to the R. Again here you can have, just you are going to the end, so you have to further scan either for A and go to the R, or you have the B, replace with B and go to the R. So A, replace with A, go to the R. You are not changing the tape symbol, just going to the right. And whenever you have the blank symbol, whenever you have the blank, so whenever you have found blank, replace with blank and come to the left. Whenever you are at the left, if it is the case of correct, then you will have the, since you have deleted the B, you will also having the B here. So for the case of B, the first symbol is B and last is also you are going to match the B. So if this is the B, replace with blank and come to the left. Again A, replace with A, come to the left. B, replace with B, come to the left. And whenever you have the blank, replace with blank, go to the R. Now this is the way. But how you can show the case of the acceptance? So for the case of acceptance, there are two situations. You have the your input can be of even length. Once, say for example, if you have the a, if you are given a, this is the even length palindrome. So at the q0 you have the blank, replace with blank, go to the r, and you have replaced with blank symbol, go to the r, and at the state q2 a, replace with it, go to r. So okay, you have deleted a with blank and go to r, means you are now here. Whenever you are at the q2, replace q2, at the q2 you have the a, replace with a and go to the r, and at the right you have the blank symbol. So whenever you have the blank, come to the left. So you are here, means at q3. So at q3 you have the blank symbol. Okay, so you have the blank. At q3 you have the symbol a, and you are deleting this, and means it becomes the blank, and come to the left. So you are here actually. So whenever you are blank, go to the right. To blank, go to the right, and right is also blank. So from this position, once you find the blank symbol, so whenever you have the blank, okay, so you are going to the HA, and this is the case of even length. So for the case of even length palindrome, okay, so you are going to accept from the state q1. Now see, whenever you are having the only odd situations like b, if you have only single symbol, string of length 1, and you have only b, and this is the odd length string. So what you can say, you are at here and you have the b, you are replacing b with blank, so you are blank and go to the right, and right is what? This is the blank. So you are at the q5 and you see that blank is there, and replace with blank, come to the left. Once you are coming left here at the q6, you have the blank symbol. So you have just deleted that is the midpoint. So this is the blank symbol. So once this is the blank symbol, it means this is the case of the odd length string. So from here, from q6, you can see from q6 you can go to the h. So for what? You have the blank, replace with blank, you may move to the right, there is no issue. And here also you have the blank, replace with blank and move to the right, and you are going to, and this is what? This is odd length, odd length. This is odd length. And similarly at the state q3 also, from state q3 you have to go to the HA for the case of the odd length. So accepting the odd length string from the state q3, you have to go to HA. For what condition? If you have the blank, replace with blank, go to the R. This is so. So odd length you are going to accept from the q3 and q6, and even length palindrome you are going to accept with from the state q1. So at the beginning this can be null also, you know, this is null also. So that's why if it is null, then you have the only the tape contains this kind of information. So at the square 0 you have the blank, and at the square 1 also you have the blank. So once you have replaced, once you are at the state q0, you found that your tape head is scanning the blank symbol, replace with blank, go to the R. Once you are at the state q1, again you have the blank symbol, and means there is nothing in the tape. So you are replacing the blank with blank and go to the R. You are moving the tape head to the right and jump to the accepting states, halt state. And this is the case of even length string. So these are the two 3 points where you are going to accept it. From the state q1, if you found the blank symbol, then you are going to the halt state for the even length. From the state q3, if you found the blank symbol, go to the halt state. If you are at q6, found the blank symbol, go to the halt state. So now see, if you have the situation like this, if you are given the input A, B, and this, if you may be given the input like this, so you are following this path. Whenever you are at A, you have replaced with blank and go to the right. And right is what? This is the B. So you have the B replaced with B, go to the R. And right, you are at this place now. So you are scanning the blank. So blank replace with blank and come to the left. So you are at the left, means you have the B. You are at the B. Now, whenever you are at the Q3, what you are expecting, since you have deleted the A, then last symbol must also be A. But here you have the situation different. You have deleted A and last symbol is encountering the B. This is not the correct way, or this is not the case where you can say that this is the palindrome string. So this is the situation where your machine explicitly decides that okay, this is not in the language of palindrome. This input is not in the language of palindrome because first symbol is A and last symbol is B. So you have the first is A and last instead of A you have found the B. And see, at the Q3 actually we have not mentioned the transition for the B because we don't want such transition. And if you are at the Q3 and if you found that your machine, your Turing machine found that okay, the square under the head position is scanning the symbol B, whereas we are expecting the symbol A. So this is the situation of crash. So your machine is going to crash. Once your machine is going to crash, means if you are at the Q3 and you have the symbol B, instead of A you have the B, then your machine actually goes to the HR state. And your machine is explicitly decide that okay, the given input is not in the language and hence I am going to crash. Once your machine goes to the HR means the input is not in the language. This is the case of rejection. However, we don't require to, for the simplifying the diagram, we don't require to show explicitly that machine is going to the HR state. Actually, it happens once machine is at the Q3 and it is observing the symbol B instead of A, machine is going to crash. Once machine is at the state Q6, if you have instead of B, if you have the A, then this is the situation of crash and your machine is going to crash. So in all acceptable situations, you have, if here is A, then here must be A. If here is B, then you must also have the B. And see that this is the Turing machine for the language of palindrome. And this is the deterministic Turing machine. This is the deterministic Turing machine you have obtained for the language of palindrome. And whereas you know that in case of the PDA, we don't have the deterministic PDA for the language of palindrome. Okay.